Hey everyone, in this video we are going to be talking about dimensional analysis. And dimensional analysis is basically a fancy way of doing conversions. And what we mean by conversions is that we are going to be converting from one unit to another. And we're going to be using those SI units that we talked about before. So, with our conversions, we use a conversion factor, which is a ratio of equivalent measures. So, for example, let's say that we had $1. Well, if I have $1, that could be 100 pennies. Those are the same measurement. They are both going to be $1, whether it's a dollar bill or 100 pennies or 10 dimes or whatever. If we have 60 minutes, 60 minutes is also going to be equal or equivalent to 1 hour. They're measuring the same thing, they're just using different units. Now, here's why we can do this dimensional analysis or conversions. When you multiply by a conversion factor, the value changes. And whenever we say value, we're talking about the number. So the value changes with the units, but not the actual size of the quantity measured. So basically what we're saying is, okay, yes, we know that we are going to be converting between units. When we do that, the number is going to change. However, the actual size of what we are measuring is not going to change, because if I look at $1 equals 100 pennies, both of those are measuring a dollar. It's just different units. That's what we're saying here. Okay? Now, let's talk about what the actual definition of dimensional analysis is and how it relates to this idea of conversion factors or this equivalent measures. So, dimensional analysis is a systematical, so that means that we're going to have a certain process or system that we follow, approach to problem solving that uses conversion factors. And you're probably going to hear me call them relationships, because I'm wanting to figure out how are these two units related. For example, $1 is related to pennies because 100 pennies is $1. So we use our conversion factors or relationships to convert, which is the same thing as saying we're going to change from one unit to another. Okay, so again, we're going to have a certain process that we follow in order to perform this dimensional analysis or conversion. And it's important to note that in order to make a conversion, you need the relationship between what you have, meaning the thing that you are given, and what you are converting it to. Which is your unknown. So basically, we have to figure out a way to go from our given to our unknown. And that is called our unit path. And the reason is, again, we are going to be converting from one unit to another. We're changing units in this. So our unit path is, I'm going to start with this unit, use a certain relationship, and change it to a different unit. Now, if you notice, we're talking about given and unknown. So we are going to be using the guess method in order to do this. So let's look at our first example. And this is going to be more of a practical example of something that we may encounter in our everyday lives. So we need to convert $3 to quarters. So we start with our given. In this case, we are given our $3. Our unknown, or the thing that we're trying to get to, is going to be quarters. Now, we don't necessarily know the number of quarters yet. We just know that our unit, or the thing we're trying to get to, is quarters. Now, for the E part of our guess method, this is going to be our unit path. So we don't have an equation to plug and chug into. We're trying to figure out, how am I going to change my units? So we start with dollars, and then we're trying to get to quarters. Well, I have to think to myself, blank dollar equals blank quarters. Okay? Now, up here where I wrote dollars to quarters, that is my unit path. That's how I'm showing my units are going to change. Down here where I have blank dollar equals blank quarter, this is that relationship or that conversion factor. So with this, we know that $1 is going to be 4 quarters. So those are measuring the same thing. They're measuring $1. Now, what I'm then going to do is, I can't really do a lot of math with this yet. I need to change the way that I'm writing it. So we're going to turn it into a fraction. So we're going to say $1 over 4 quarters, or we can do the reciprocal. 4 quarters over $1. And the reason why we can write these as fractions is because they're measuring the same thing. Okay? Now, you may be thinking to yourself, well, how do I know which fraction that I'm actually going to use? Your units determine which one you use. And you might be like, well, I don't really get what you mean by the units. That's where our final step comes in. So if I am starting with $3, okay, that is my first unit. I'm then going to multiply by one of these fractions. And if you remember, we're trying to change our units. So I'm trying to go from dollars to quarters. Well, in order to do that, my unit of dollars has to cancel out. And in order for that unit to cancel out, whatever is on the top, meaning right here, this is my top, then has to be on the bottom. So I'm going to have my dollars on the bottom. So again, whatever's on the top has to be on the bottom to cancel out. And then the thing I'm trying to get to, which in this case is quarters, goes on the top. And then we fill in with our 4 quarters and $1. Now, I think that it is very helpful to highlight the fact that my dollars are going to cancel out, and then I'm left with the thing that I want, which is quarters. And then the way that you actually go about multiplying and dividing is you do everything on the top, so 3 times 4, divide it by everything on the bottom, which in this case is 1. And whenever you do that, you're going to get 12. So 12 quarters would be your answer. Okay. Now, let's talk about this in terms of the way that you would see this in a chemistry setting. Whatever unit you start with has to be on the bottom to cancel out. Meaning that those units are going to cancel out. So again, whatever's on the top then goes on the bottom. The other thing that we have to know, and this goes back to our prefixes that we've talked about previously. Bigger prefix / unit gets a 1. The other prefix / unit gets the factor associated with the prefix. And you might be like, well, I am completely lost right now. I remember doing the bigger prefix, the smaller prefix, but I don't necessarily understand about the 1. That's what we're going to look at now. So you need to go back and you need to pull out this chart. So you should have this chart, but you want to make sure that you have it out. That way you can go and refer to it, because this chart is going to be your best friend whenever you are doing your conversions. Okay, so let's go through and figure out some conversion factors. So let's say we had blank kilogram, and your base unit could be anything, equals blank gram. Well, we go through and we figure out between kilogram, which is right here, and the gram, which is the base unit, which one's bigger? Bigger means that you are higher up on the chart. So the kilogram is bigger, it gets a 1. Now, I go and I look at kilo, and I see the factor that's associated with it is 10 to the third. So that means that this 10 to the third goes with the gram. Because what we are saying is that 1 kilogram is the same thing as 10 to the third or 1,000 grams. Because if you remember what we talked about with SI units, that prefix kilo means that you are 1,000 times larger than that unit it precedes, in this case the gram. That's why this works. So if we had megagram and gram, we go through, we see which one is bigger, aka higher up on the chart. In this case, mega is higher up on the chart. It's bigger. It gets the 1. The gram gets the factor that's associated with it. In this case, it's going to be 10 to the 6. And again, that's because here's mega. Its factor is 10 to the 6. Now, let's look at if we had milligrams and grams. Well, this time, keep in mind that gram is my base unit, so I'm right here, and then milli is right here. So in this case, gram is actually going to be bigger. Now, whenever I go to look at the gram, okay, the gram doesn't have a factor that's associated with it. So in this case, we're going to be looking at milli, and its factor is 10 to the third. Because if you remember, milli, for milligrams, you are 1,000 times smaller than your base unit. So what we're saying is that this smaller unit, it's going to take more of it to be an equivalent measure of your bigger unit. Okay? Now, I want you to pause and I want you to go through and I want you to do the same thing for centigrams, micrograms, nanograms, and pico. So again, take a moment, pause, come back, and then we will go through. Now, I trust that you have paused. On all of these, your gram is going to be your bigger unit. It gets the 1. And then the rest of these are going to get the factor. Now, all of this that we have just done is an important step in order to go through and solve our dimensional analysis problems. Okay, so we have to use what we just did about the bigger unit, but then we also have to use what we did up here about our units canceling out as well. So let's go through and let's do an example. So let's say we need to convert 546.5 centigrams to grams. Well, first things first, we got to figure out what we're given. In this case, we're given the 546.5 centigrams. And then our unknown, or the thing that we're trying to get to, is going to be grams. And again, we don't necessarily know how many grams it's going to be. We just know that our unit is the gram. So now, we need to figure out our unit path. Basically, how am I going to be able to do this, to change my units? So I'm always going to start with my given. That's always going to be the first part of my unit path. And then I'm going to go to grams. So again, that's my unit path. But now I have to figure out what is the relationship between centigrams and grams using my chart. So how many centigrams is going to be equivalent to the gram. So how many centigrams equals blank grams? This is where I go to my chart and I figure out which one is bigger. Is it centi or the gram? And remember, gram is a base unit. So gram is here, centi is here, gram is bigger, so it's going to get the 1, and then the centi is going to get the factor. In this case, the factor is going to be 10 to the second. Okay, now we can go through, we can substitute in and solve. So I'm going to start with my given, which was the 546.5 centigrams. We're going to be multiplying. And then this is where I have to figure out that fraction. And notice I didn't write out the two options for the fractions because I don't have time for that and I don't need to do it every time. Because whatever unit starts out on the top then has to go where? On the bottom. Now notice I'm using these colors. That just helps me to identify centigrams was on the top, centigrams now has to go on the bottom. The thing that I need, that I'm trying to get to, is the gram. It's going to go on the top. And now what I'm going to do is I'm going to plug in the numbers from this relationship. So what I mean by that is if 1 was with the gram in my relationship, 1 is with my gram in this fraction. 10 to the second was with centigrams in my relationship. It stays with it in my fraction. Okay? Now, one other thing that I want to point out here before we solve is that there's understood to be a 1 underneath this 546.5. We just don't write it, okay? But it's understood to be there. And the reason why I mention that is because whenever you go to solve this, you're going to take your 546.5 and you multiply it by 1 because you're doing everything on the top, divide it by everything on the bottom, which is technically a 1 times this 10 to the second. Okay? Then we're going to be left with 5.46 grams. Now you might be thinking to yourself, how do you know that it's grams? Because my units canceled each other out, I was left with gram. Also, you may be thinking to yourself, well, Ms. Dupuy, you really just moved the decimal place. And you're right, I did really just move the decimal place. Just moving the decimal place is a cheat way of doing dimensional analysis. For what we are going to be doing later on, you need to get a hold of this now about your units canceling each other out and then how we go about that. So, let's look at another example. So, let's say that we need to convert 25 kilograms to grams. So, we're going to start out with our given, which is 25 kilograms. Our unknown, or the thing we're trying to get to, is going to be grams. So, we have to figure out, first off, what is that unit path? Well, the first unit I'm going to start with is kilograms. The next unit I'm going to go to is grams. Then I have to figure out the relationship between the two. So, blank kilogram equals blank gram. This is where I go back up here to my chart, and I see that kilo is bigger than gram. So, kilo gets the 1, and the gram gets the factor, because what we're saying is that it takes 1,000 grams to be the equivalent of 1 kilogram. Now we're going to go through and we're going to solve. So you always start with what you're given, which in this case was the 25 kilograms. Now, if I start with kilograms on the top, what has to go on the bottom? The kilograms. And then the thing I'm trying to get to goes on the top, which in this case is grams. So again, whatever's on the top originally then goes on the bottom, speaking in terms of units. And then we plug in from our relationship. So 10 to the third was in the grams in my relationship. It's with it in my fraction. 1 was with the kilogram in my relationship. It's with it in my fraction. Okay? Now, again, whenever you plug this in, you're going to have 25 times 10 raised to the third over 1. And you don't have to do the over 1. I honestly would just plug it in like this. When you do that, you're going to get 25,000 grams. Now, your calculator is more than likely going to give you this. 2.2 E negative 0.5. What this translates to is 2.2 E is times 10, and what comes after the E is your exponent. So in this case, it would be negative 5. So this is scientific notation. So you would have grams as your answer. And you do have to include your unit. If you don't, then it's wrong. And the reason for that is because if you don't include a unit, then that's just a number. Then that's just 2.2 times 10 to the negative 5th. And we have no idea what it actually is. Like what unit it is. Okay? Now, I want you to try on your own to convert 65 nanometers to meters. So you go through, pause the video, work it out, and then come back and check and see how you did. So I trust you have paused the video. And we're going to start out with our given. So in this problem, we're given 65 nanometers. And we're told that we need to convert it to meters. So that is going to be our unknown, the thing that we're trying to get to. So we first have to figure out our unit path. So what is the very first unit I'm going to start with, which is going to be the nanometers. And then what unit am I going to change it to, or am I going to try and get to? In this case, it's meters. Well, then I have to figure out that relationship. Blank nanometer equals blank meter. I go up to my chart, and I figure out which one is bigger. So between nano and the meter, which one is bigger? In this case, it's meter, the base unit. So it is going to get a 1. And then the factor is going to go with nano, which is 10 to the 9th. And remember, what we're saying is that it takes 10 to the 9th nanometers to be equivalent to 1 meter. And now we're going to solve. So we start out with our given, which was 65 nanometers. If we have nanometers on the top, then what unit has to go on the bottom? The nanometers. And then the thing we're trying to get to, which in this case is meters, is going to go on the top. And then we plug in from our relationship. So the 1 was with the meter in the relationship. It's still with it in the fraction. 10 to the 9th was nanometers. It's still with it in the fraction. And whenever you go through and you do that, your calculator is going to give you 6.5 e to the negative 0.8. I don't want to see it that way. I want to see it as 6.5 times 10 raised to the negative 8th. And then remember, I have to have my unit included as well. If you don't have the unit, then it will be wrong because I don't know what you are talking about. Okay, and that is going to be it for our single step dimensional analysis.